I hope everyone's doing well today. I'm Mr. Ish. Thank you for joining me for this interesting geometry exercise requested by a particular viewer. And what was that he was requesting? If you have here a circle, you draw from one end to the other end a diameter going to the center. You have a specific point here, P. We connect the ends of the diameter to that point P. What are we generating? An inscribed triangle. But specifically, it's going to be a right triangle or a right angle triangle. Why would this be a 90 degree? Well, that's not the subject of this video because I've already shown that in another video, and I'll include the link for that video in the information for this. But in general, why will this turn out to be a right triangle? I will tell you in this video, and that was the request from that student. You can start by generating here an x and y axis. This right here represents my center 0, 0. If the radius of this circle is r, this point must be r, 0. This point here must be minus r, 0. We need the points of this x and y, and you know you can determine it. It's not hard. If you have a unit circle and you draw here a specific point and you connect them by means of a radius and downwards, and you create this right triangle, you have an x, you have a y, you have a radius r, you have a certain angle theta. You can bring parametric equations into play and they'll give you the values of x and y. Cosine theta is equal to x over r. X is equal to r cosine theta. Sine theta is equal to y over r, and y is equal to r sine theta. These circled items are parametric equations. Theta is your parameter and they give you the values of x and y. That's what they are. So we know here x must be r cosine theta, and we know y must be r sine theta. These represent your point P. Think about this property: a square plus b square is equal to c square for a right triangle, and it holds true. If I'm calling this c, I'm calling this a. If I'm calling that b, and I can determine the lengths of these segments and run them through this, if they check out, they're good, then we know we are looking here at a right triangle, or you can say a right angle triangle. What will be my segment A? You will be thinking here about the distance formula of a length of segment: square root of y2 minus y1 whole square plus x2 minus x1 whole square, and that's going to give you your length. What are my coordinates? I have my coordinates r, 0, and this r cosine theta, r sine theta. These are my things. I'm going to run them through. I'll have here is 0 minus r sine theta whole square. This is my y2 minus y1 whole square plus x2 minus x1, r minus r cosine theta whole square. Now what about my b? You know you have the coordinates for b: minus r, 0 and x, y, which are these. You can easily determine from these endpoints of that segment the distance of that segment by this formula. You will have here 0 minus r sine theta whole square plus minus r cosine theta whole square. What about segment C? It's the easiest. Why is it the easiest? Because it's your diameter. Diameter is twice the radius, and it makes sense. R minus r is a 2r, and that's it. If A represents this, B represents this, the square of those components will eliminate the radicals. Think about it. If I have a particular item in a square root and I'm squaring it, these cancel out. I'm left only with the inner component, which is x. The inner component is all this. The squares will eliminate the radicals. So the a square will be basically these items expanded. You'll have a r square sine square theta plus expand this. You'll have an r square plus r square cosine square theta minus 2r square cosine theta. It's basically a minus b whole square, which is a square plus b square minus 2ab. This right here represents my a square. Now we'll do our b square. We have to expand that out. Again, the square will cancel out the radical. I'll have here an r square sine square theta plus. We have to expand this. R square plus r square cosine square theta. Here you're going to have a plus 2r square cosine theta, because when you do the ab component, the minus will cancel out. You'll have a r square cosine theta with a 2. This here represents my b square. What's my c square? If c is this, my c square is equal to 4r square. We have to do our simplification. Look, this cancels out with this. I have an r square, they'll become 2r square. I have this r square sine square theta and r square cosine square theta plus r square sine square theta plus r square cosine square theta. These are duplicated. Look at them only once and multiply by 2. You have here an r square sine square theta plus r square cosine square theta. I'm just using abbreviations. Isolate the r square. You'll have a sine square plus cosine square. But by means of a trigonometric identity, this is equal to 1. You are left with only r square. From this here I'm getting a single r square. From this here I'm getting another single r square. That's another 2r square, and it should equal to 4r square. This here represents my a square plus b square. This here represents my c square, and you know it's looking good. 4r square is equal to 4r square, and we're done, and everything checks out. So indeed, when you connect the endpoints of a diameter to a third point and you create a triangle, it must be a right triangle, or you can say a right angle triangle. And we are showing you by not focusing on this particular angle, but in general by means of this property of a right triangle. That's it. Thank you for watching. Have a great day.